In this video, we're going to talk about 2.6 Objective 7, where we solve applications involving continuity principles. Let's go ahead and look at number 1. You are shopping for a $300,000 30-year, that's a 360-month loan to buy a house. The monthly payment is given by the following formula, where R is the annual interest rate. Suppose banks are currently offering interest rates between 3% and 4%. Complete parts A and B. So M, your monthly payment as a function of R, is equal to 300,000 times R over 12 divided by 1 minus the quantity 1 plus R over 12 raised to the negative 360th power. That's your monthly payment formula. So show that there is a value of R in the interval of 3% to 4% that allows you to make monthly payments of $13,000 or $1,300 per month. So I'm going to have to copy this into Desmos here. Just give me just a second to do that. Math tools, graphing calculator. M of R is equal to 300,000 R over 12 divided by 1 minus 1 plus R over 12. That's raised to the negative 360th power. And we're looking on the interval between 3% and 4%. And we want our monthly payment to be, what was it? $1,300 a month. So let's go between 1,000 and 1,500. I want Y equals 1,300. So there's the value right there that we're looking for in just a second. But let's use the intermediate value theorem. Let's prove we can use it. The numerator of M is continuous on the interval from 3% to 4% because it's a linear function. The denominator of M is also continuous on 3% to 4% because it is a rational function whose denominator is not equal to 0 for any value of R in the interval of 3% to 4%. Therefore, the function M is continuous on the interval of 3% to 4% by the polynomial and rational functions theorem. So now we need to evaluate at 3%. So M of 3% is 1,264.81. And 4% is 1,432.25. And 1,300 is between there. So since 1,300 is between M of 3% and 4% by the intermediate value theorem, there exists at least one number C in the interval satisfying M of C equals 1300. And we have the curve here. It's an exponential curve, but if we're looking from 0 to 10%, let's fix this. 0 to 10% going by 1, 2, 3, 4, 5, 6, 7, 8. So it looks like we're going by 0.05. And then Y is going from 0 to 5,000 by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 by 500s. So 0 to 5,000 by 500s. Then we can see that nice curvature there, and we can see that it is C. And the R value that we're looking for to 4 decimal places is going to be 0.0322. This was continuous, not equal to 0 for any value, continuous, and then exists at least 1. All right, let's move on to the next problem here. Suppose $3,500 is invested in a savings account for 11 years, which is 132 months. With an annual interest rate of R compounded monthly, the amount of money accrued in the account after 11 years is A of R equals 3,500 times 1 plus R over 12 to the 132. Use the intermediate value theorem to show that there's a value of R between 0 and 8%. That allows you to reach your savings goal of $7,000 in 11 years. So first thing is the F is going to be continuous on the interval A to B here, closed, and L is a number strictly between F of A and F of B. Then there exists at least one number C in the open interval A, B, satisfying F of C equals L. That is my intermediate value theorem. For what values of R is A continuous? It's continuous for R, all R values. A of 0 is going to be 3,500 because if you don't earn any interest, you just keep your principal. 8%. So 3,500. Let's clear these out. 1 plus 8% divided by 12 raised to the 132nd power, 8,413.54. It says round to the nearest integer, so it's 8,414. And our goal of $7,000 is definitely between 3,500 and 8,414. So let's see here. Yeah, it can be used because A is continuous on the interval from 0 to 0.08, and 7,000 is between A of 0 and A of 0.08. Let's go ahead and graph this with a X in there. And we're going to look at this on the interval from 0 to 0.8 by 0.2s. 0 to 0.08 by 0.02. And then we want to go 0 to 20,000 by 5,000s. Okay. And then we want the other thing here, y equals, our goal was 7,000. So right there. And r is going to be about 0.6 3. So that's the same as 6.3%. We'll round it to the nearest 1/10 of a percent. And this is continuous on the interval of A to B like this, strictly between. There exists at least one on the open interval A to B, f of c equals L. And this was, sorry, which one was this? That looks like B. All right. Let's go ahead and assume you invest $240 at the end of each year for 10 years at an interest rate of R. The amount of money in the account after 10 years is A equals 240 times the quantity of 1 plus R to the 10th minus 1 divided by R. Your goal is to have $3,174 in your account after 10 years. So let the function f of x be equal to this. They should be calling this f of r. Or they should be putting an x in there in the place. They have a mismatch with their variables, so go ahead and fix that for yourself. It's okay to call this f, but make this x the same here, or replace that x with an r. And you want to be between 1% and 10% for your interest rate that's getting offered to you. Show that you can meet your goal. So let's go ahead and check here. Is the function continuous there? Let's check that first. 240 times 1 plus x raised to the 10th power minus 1 divided by x. And we want to look between 1/10 and 10, or 1/100th and 10/100ths. So 100th and 1/10. It looks continuous to me on that interval. And then let's go ahead and see. Our goal is 3,174. And yes, 100th is going to be less than that down here, and 1/10 is going to be greater than that, and there's going to be a value in between. So yes, because the function is continuous on that closed interval, and 3174 is between f of 100th and f of 1/10. That's B. Now use the calculator to say what that value is, and it is 6.07%. When we go to the 2 decimal places there this time. So watch out for where they tell you to round. Number 4 here. Suppose you park your car at a trailhead of a national park and begin a 4-hour hike to the lake at 9 a.m. on a Thursday morning. On Sunday morning, you leave the lake at 9 a.m. and start the 4-hour hike back to your car along the same trail you took to the lake. Assume the lake is 5 kilometers from your car. Let f of t be your distance from the car t hours after 9 a.m. on Thursday morning. Let g of t be your distance from the car t hours after 9 a.m. on Sunday morning. Compute parts A through C below. So f of 0 is going to be 0. F of 4 is going to be 5, because after 4 hours, you get all the way to the lake, which is 5 kilometers from your car. G of 0 is going to be 5. And G of 4 is going to be 0. Supposedly, it's taking you the same time, 4 hours to get there and back, probably a level trail. H of t equals f of t minus g of t. Find h of 0 and h of 4. So at 0, we have 0 minus 5 is -5. And at 4, we have 5 minus 0 is 5. Use the intermediate value theorem to show that there is some point along the trail that you will pass at exactly the same time on both days, where the difference will be 0. So 0 is definitely between -5 and 5 somewhere. There's a 0 point where you pass the same point at the same time. So C, since h of 0 is less than 0 and h of 4 is greater than 0, there must be 1 times C between 0 and 4 satisfying h of C equals 0. If h of C equals 0, then f of C equals g of C, and you're at the same point along the trail C hours after 9 a.m. on both days. So that's it. We didn't actually find what time or what point. We just proved the existence of such a point with the mean value theorem. So a monk set out from a monastery in the valley at dawn. He walked all day up a winding path, stopping for lunch and taking a nap along the way. At dusk, he arrived at the temple on the mountaintop. The next day, the monk made the return walk to the valley, leaving the temple at dawn, walking the same path for the entire day, and arriving at the monastery in the evening. Must there be one point along the path that the monk occupied at the same time of day on both the ascent and descent? And the question can be answered without the intermediate value theorem is your hint. So yes, if a second monk was tracing the monk's path up as the monk climbed down, at some point the 2 monks would cross paths. So we don't even need to use the intermediate value theorem to think about that they would at some point have to cross paths if they're taking the same trail like that. So yes. All right, that is it for this video, and we'll come back next time and we'll talk about 2.6 Objective 8. See you for the next video.